Right, so one of the things we started talking about is hydrocarbons. And so hydrocarbons are exactly what they sound like. They're made of carbon and hydrogen. And so the first thing that we're going to look at, sorry, get the pen going here. The first thing that we're going to look at is what's called an alkane. And alkanes are going to be when everything contains single bonds. So over here are pictures of the alkanes. So you have methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. And so the prefixes, the meth, the eth, the prop, the but, the pent, the hex, hept, oct, non, dec, those are all going to be the same for these hydrocarbons. The difference is if it ends in ane, that means everything is single bonded. So methane has a chemical formula of CH4, okay? Ethane has a chemical formula of C2H6. And how we come up to this conclusion is that the alkanes have a formula that says CnH2n plus 2. So if there's one carbon, 1 times 2 is 2 plus 2 is 4, you get your CH4. If there's two carbons, C2, 2 times 2 is 4 plus 2 is 6. Okay, so this is the formula for alkanes. So propane then, is C3H8, butane is C4H10, C5 is H12, and not all the H's are being shown there, they kind of ran down there. Hexane is C6H14, heptane is C7H16, octane is C8H18, nonane is C9H20, and C10 is H22. Now you want this formula because you don't want to draw these out, and they get bigger and they get crazier, but you don't want to draw it out. You want to be able just to throw it in the formula quickly and figure out how many there would be. Okay, so the alkanes are single bonds. These are the structures of them. Methane is the smallest one we have. These are all saturated because they're all just a single bond. So every one of these guys is a saturated hydrocarbon. Okay, well, we can change this to an alkene. And alkenes contain double bonds somewhere. All right, so obviously I can't double bond methane because there's nothing to double bond with. But ethane, I can double bond those carbon and finish up with my hydrogen. So that carbon's got 8 every time. So 1, 2, 3, 4, 1, 2, 3, 4, we're good. Okay, chemical formula for this is C2H4. All right, when ethane was C2H6. The name of this is ethene because at the start of this, you have 2 carbon. So your prefix is eth, okay, because the 2 means eth. The 3 means prop, 4 is but, so on and so on. But the ending changes because you're now dealing with a double bond, and that's an alkene. All right, so this is going to be what we do for our alkenes. The formula is CnH2n. So let's go to this guy. 1, 2, I'll do the double bond there, and I'll do this. So these guys would be hydrogens. All right, I'm just not going to fill them in. All right, so let's look at our formulas. So Cn, so C4, 1, 2, 3, 4, and H2n, it should be H8. Let's see if that's right. So 1, 2, 3, 4, 5, 6, 7, and 8. So we're good. That's our formula for this. Now we have to name this guy. So 1, 2, 3, 4. All right, so he's going to be but. He's got a double bond in there, so he's butene. But you have to tell me where that double bond is. So when counting, we count closest to the double bond. So 1, 2. Double bond's on the second carbon. Go this way. 1, 2. This is called 2-butene because on the second carbon, if I count this way, 1, 2, 3, 4, the second carbon contains the double bond. Okay, if I flip this whole thing, it's still on the second carbon. Now, let's change it a little bit. So I'm going to erase this. Oops, maybe too much. Let's try just a little bit there. All right, see if that does what I need it to. All right, now, what if we do this? Let's go 1, 2, 3, 4. Do that. Okay. Fill in my hydrogen. That looks horrible. That's sorry. There. Okay. Ignore this guy. All right, these guys are hydrogens. So I'm going to count up my base. 1, 2, 3, 4, 5, 6. So 6, the prefix is hex. There's a double bond in there, so it becomes hexene. Now you got to tell me where that double bond is. So if I count this way, 1, 2, 3, 4. If I count this way, 1, 2. You have to go from the shortest end. This is 2-hexene. It at that point in time tells you where that double bond is located. It's on the second carbon of your hexene chain. Okay, last thing for this video, and then I'm going to cut this one short, and then I'll create another video for the other way we can mess with these guys. Okay, so we've talked alkanes, alkenes. We're going to go one more to what we call alkynes. Okay, alkynes are going to contain a triple bond. So you keep the same prefixes, but now there's going to be a triple bond somewhere involved. Okay, the formula for this is going to be CnH2n minus 2. So let's go 1, 2, 3, 4, triple bond it, 5. Okay, we'll go another one over here for fun. Okay, fill in my hydrogen here. That guy's good. That guy's good. Boom, 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 boom. All right. So my formula, I've got 1, 2, 3, 4, 5, 6, 7, and 8. So it's C8. Now, according to this, I should be 2N, so 16 minus 2, H14. Let's check and see if that's right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, and we're good. So here's my formula for this guy. Now, 8 is my longest chain, so it's oct. There's a triple bond in there, so it's going to be octyne, okay, because the alkynes are the triple bonds. Now, we got to count where that triple bond is. So 1, 2, 3, 4, 5. 1, 2, 3. 3 is the shortest path. 3-octyne is your name. So alkanes are going to be single bonds. Alkenes, or if there's a double bond, and alkynes would be if a triple bond. The next video is going to talk about what happens if you've got double bonds in 2 places or a triple bond somewhere. What's going to happen if we call what's called methyl and ethyl groups as well. So this is your first introductory video just to the basic hydrocarbons, and then the next one's going to take it up just a little bit. This is the stuff that will be on Friday's quiz, but it's also going to be on the 4th study guide as soon as I get a chance to fix things.